Good afternoon, everyone, and welcome to the webinar titled Future of Semiconductor Manufacturing. I'm Himanshu, and I'm your moderator for the day. Did you know that semiconductors are the essential building blocks for every modern electronics? They are used in everything from smartphones, laptops, to cars, and even in medical devices. The medical semiconductor industry is expected to reach over 1 trillion by 2030. The semiconductor manufacturing industry overall is constantly evolving with new technologies and processes which are being developed all the time. The webinar that we have organized with the experts we have today, we want to explore the future of semiconductor manufacturing and discuss the challenges and opportunities that lie ahead of us. Here are some of the interesting stats that I found while researching for the semiconductor manufacturing industry. Did you know that an average semiconductor chip consists of over billions of transistors? And even the cost of manufacturing a small, teeny tiny chip of semiconductor has decreased exponentially from 50% over the decades for the past 40 years. And coming to the questions that we plan to explore, that we want to get answered from our experts joining today are that what are the key challenges, what are the opportunities that the semiconductor industry in general is facing, and are there any trends and how it is going to shape in the next decade or two. Today, we have a great line of speakers for this webinar, and I'm excited to learn from them and discuss the future of semiconductor manufacturing with all of you. Joining from in-house research team is my colleague Achal and Nitika. They have rich experience of consulting, and they are a decade old into this, and they look after the ICT and electronics department over here at TechSci. Welcome to you.
Thank you, Manshu.
Thank you, Himanshu. Good afternoon, everyone. I'm Achal. Thank you, Himanshu, for such a warm welcome. So, just to start with, I'm just here to give you the introduction of semiconductor manufacturing in India as well as global. Semiconductor. What is semiconductor? A semiconductor is a material possessing distinct electrical properties that render it suitable for serving as a foundation for computer as well as various electronic devices. It is also used in consumer electronics. Basically, there are two types of semiconductor: intrinsic and extrinsic. Intrinsic, basically, it is a pure form of semiconductors, and if we do doping in that, it become extrinsic semiconductors. Various components of semiconductors include like memory, which is a very important component of semiconductor, micro component, analog, logic, optoelectronics. It is another important component of semiconductor which is utilized for guiding, detecting, modulating, and to a limited extent generating optical signals too. Another major component is sensor, then discrete components, which is characterized by a fundamental non-subdivided functions. This is a small representation of manufacturing of semiconductors. Semiconductor manufacturing is not easy, is not as well as difficult, but it is going through different process. There are 11 steps we need to follow to manufacture semiconductors, which is cleaning, film deposition, post deposition cleaning, resist coating, exposure, development, etching, implantation of impurities, activation, resist stripping, and then the assembly of semiconductors. This is the final step while manufacturing the semiconductors. If we talk about Indian scenario, we know that right now India is based on imports. It's heavily relies on imports, and domestic semiconductor manufacturing is in the very early stage of India. Although India is focusing on becoming a digital economy and has established numerous government programs like Digital India, Skill India, Smart City India to become a very good digital economy, and in that semiconductor plays a very important role. The government is strategically positioning itself to become a prominent hub for chip manufacturing, especially in light of global semiconductor shortage and the increasing demand for consumer and electronic products. Consequently, the government has implemented a large number of initiatives and policies to fulfill this objective. India plans to expand its global market share across all the phases of semiconductor production, like design, fabrication, assembly, test, and packaging. Also, the Indian government has implemented a scheme to promote semiconductor manufacturing with a notable emphasis on display fabs, packaging and test facilities, and chip design centers. It will also employ a large skilled workforce. The Indian federal government, alongside the governments of leading states like Gujarat, Karnataka, Tamil Nadu, and Telangana, is working extremely hard to understand the address, the needs, the challenges, the opportunities, the drivers of semiconductor enterprises across a wide range of areas like regulations, taxation, policies, infrastructure, logistic, incentive, and customs. This is a very good policy, India Semiconductor Mission, in which the vision of Atmanirbhar in electronics and semiconductors was given further momentum by the Union Cabinet, which was chaired by the Honorable Prime Minister, and they approved around USD 9,151 million for the development of semiconductor and display manufacturing ecosystem in our country. Various policies and initiatives apart from the semiconductor mission in India are electronics manufacturing cluster scheme, national policy on electronics, production link scheme for large scale electronic manufacturing, Atmanirbhar Bharat, digital economy, national policy on electronics 2019, modified electronic manufacturing clusters scheme for promotion, and various government bodies which basically finalize these policies, scheme, duties are Ministry of Commerce and Industry, India Electronics and Semiconductor Association, Ministry of Electronics and Information Technology, Electronic Industry Association of India, National Institute of Science and Technology, that's in Odisha. This is a small business model. We can say it's a semiconductor ecosystem which tells about the manufacturing of semiconductors, that is research, designing, manufacturing, assembly, testing, and packaging, and finally, it's distributing. Over to you, Nitika.
Hi, good afternoon, all. As Achal explained the scenario for the India semiconductor market till now, let me add some of the insights from the tech size perspective for the India as well as the global market. As the semiconductors are the really the building blocks of the modern electronics, with the growing demand in the wide range industries like consumer electronics, healthcare, automotive, and telecommunication. The demand for the semiconductors as well as the semiconductor components are constantly increasing worldwide. As you can see, this is the global market for semiconductor. The market is around 299.52 USD billion in 2011, and it kept on increasing with the continuous growth rate till 2022. The market was 412.22 USD billion in 2017, and in 2022, the market reached to 574.08 USD billion. The market is expected to be a trillion value market by 2030, which is a double of what the market is at present. There is a slight slowdown in 2019 for the value market due to the saturation of the smartphone market associated with the US China trade war and the slowdown of the global economic during 2019. The market is actually growing with a fast pace due to the following given key factors, with a constant increase in the demand for the semiconductors. The growth drivers are like rising demand for consumer electronics, growth of IoT, advancement in AI and machine learning, growth of automotive and industrial sectors, expansion of data centers and cloud computing, growth in the demand for EVs. And if we talk about the next slide, Himanshu. And if we talk about the India semiconductor market, the market stood at 23.59 USD billion in 2019 financial year, and 34.43 USD billion in 2023 financial year. The market is expected to reach around 127 USD billion by 2029 financial year, with a CAGR of 24.32 during forecast period. The Indian semiconductor market is still in its early stages of development, and it has the potential to become a major player in the global market for the upcoming years. India has a mature semiconductor design market with a significant potential for growth in chip manufacturing, electronic design automation, and semiconductor packaging and testing sectors in the future years. Now, next slide. Now, if we talk about the five semiconductor superpower countries across the world, Taiwan leads in manufacturing, South Korea excels in export, and Japan is still expanding with the highest fabrication plants. With this, US is keep on innovating with a big share of in the market. And lastly, China, which is a key manufacturing hub, aims for self-reliance by 2030. While excluding these five manufacturing countries globally, we have Germany, United Kingdom, Malaysia, Netherlands, and Israel, who are rapidly growing in the semiconductor manufacturing capabilities. As Taiwan, with a production rank of one, has a 77 fabrication plants as of 2022 December, accounts for the 50% of the global market. Taiwan Semiconductor Manufacturing Company alone constitutes 50% of the market that serves the major tech companies across the globe. Now, as the semiconductor manufacturing industry is constantly evolving, there are number of trends that are shaping the future of the industries, which are majorly development of new materials and the processes in the market, and increasing of AI and machine learning for designing and manufacturing. And with this, the semiconductor industry do help India for shaping its economic growth too. That's all from my end. Over to Himanshu.
Thank you, Nitika and Achal, for sharing such wonderful insights about the outlook of semiconductors specific to India and on global front. And again, those insights specific to the ranking in terms of the fab of different countries was really insightful to us. Without further ado, I would like to introduce our first speaker for the webinar, Mr. Sandeep Kumar, who is a distinguished professional in the realm of technology and product management. Currently serving as the principal product manager at Oracle with an impressive career spanning over a decade, Sandeep has consistently demonstrated a keen aptitude for shaping cutting edge products and solutions that derive innovation. As a principal management consultant as a principal product manager at Oracle, he is continuing to be a driving force behind the development of innovation solutions that power businesses and organizations across the globe. Over to you, sir.
Thanks, Himanshu, and other guest and panelist. And thanks for introducing me. And yeah, as you are already highlighted that I do have a major experience majorly into the software companies, into the different domain, starting from kind of monitoring solutions to the cloud version and all. So I worked with a couple of renowned companies like SAP, CA Technology, which got acquired by the Broadcom, and that was the first company from the Broadcom to get into the software industry. But they are just again leveraging the AI solutions of CA Technology, which was earlier Computer Associates. I've also worked in the healthcare industry, which is one of the Fortune 5 country, which is a company which is United Health Group, and currently, as Himanshu already mentioned, that is I'm working with. Oracle and helping our company in contributing to the Oracle cloud infrastructure as well as the observability and management solutions, which is primarily taking care of the AI solutions. So we are investing a lot in terms of cloud technology as well as the future AI solutions from the Oracle side. So I'm excited to talk about how the software industry is getting shaped with the semiconductor, contribution and a different kind of landscape which we are seeing. I think you've already highlighted the potentials of semiconductor industry and how we are just going ahead with the positive note. So once again, thanks and thanks for inviting me to talk about this. And I'm excited to get into more into details and discussion. Yeah, thanks.
Next lineup speaker for today's event is Ketu Antani. Sir is a seasoned semiconductor engineer and technologist with a distinguished career spanning over 2 decades. He has passion for cutting edge technology, and he has played an instrumental role and has served as a driving force in shaping the future of the semiconductor manufacturing. Currently, he is working as with the Amtech Electronics India as the quality management specialist. Welcome to you, sir.
Thank you. Thank you very much, Himanshu. Good afternoon to all. I am from last 25 years with semiconductor industry. 16 years with Rotansa International Rectifier Limited, RIR, Power. I am working from diffusion section to last from the dispatch of the our devices or chips manufacturing from diffusion, alloying, all activities of the semiconductor. Minor activities of the semiconductor, photolithography is also process with I am do it my hand, and also in semiconductor after 16 years in Ratansa, there is International Rectifier Limited is the process we are adopting of the process from Italy, and after then 9 years with Hind Rectifiers at Mumbai, and that process we are doing from the West Coast, UK. We are adopting all procedure from West Coast, UK, and after we are from last 6 months I am with MTech Electronics, and here is the we are manufacturing VFDs, all thigh diode and diode modules, diode modules, thigh diode modules, or are here also we are manufacturer. Uh, so we are hope in future we are about the semiconductor. Thank you again.
Okay. Over to our last lined up speaker for today's webinar is Mr. Muthuram Swaminathan. I hope I'm pronouncing the name correctly.
Oh, just take
He's
it easy.
yeah.
Yeah.
He's a dynamic and accomplished leader in the semiconductor industry, currently serving as the CEO at Infab Semiconductor Private Limited. With a distinguished career spanning over 2 decades, Sir is widely recognized for his transformative contributions to the industry in general. As the CEO of the company, Raman continued to inspire and lead, ensuring that the company remains a beacon of innovation and a force to be reckoned with in the semiconductor sector. Welcome to you, sir.
Yeah, thanks, Himanshu, and good afternoon to everyone. As Himanshu mentioned, I am the CEO and the co-founder of Infab Semiconductor Private Limited. So, Infab, the name itself is In is for India, Fab is for Foundry. So, we were the first MEMS commercial company in India. And so, I think before I get into my company, I just wanted to give you a quick introduction of what is MEMS, okay, which is sort of an ignored topic in semiconductor. So MEMS stands for Micro Electromechanical System. Basically, seeing a mechanical structure in the IC form. Okay, so usually all the ICs what you see are 2D. Okay, I don't. Yeah, they're not. They're basically passive. Okay, and they are active also. But then MEMS is basically devices which is 3D in structure and they are movable device. So they move. Okay, unlike IC. So that's about MEMS. And again, uh, where are the application of MEMS? I think all of you use MEMS on day-to-day life. I think Sandeep's headphone has a microphone in it, which is again MEMS. Your laptop hard disk has MEMS. Your phone has MEMS, multiple MEMS devices. The car you drive has MEMS. So MEMS is everywhere. Only thing is probably we are so deep into IC we sometimes ignores. And one of the in the presentation, Anchal mentioned that there's a big market for semiconductor in the field of sensors. So MEMS addresses the sensor market. Coming back to Infab we started 3 years back, and the idea was to offer the complete turnkey solution for development of MEMS sensors within India, because as you guys have mentioned that there is a huge imports of semiconductor. Okay, and India, I think 90% of the component or the uh, electronics component which we get is are imported. So we hardly have any manufacturing ecosystem in India. Okay. So we are trying to sort of bring that in, and we are currently incubated with IAC, Institute of Science, where we use their facility because for it's a huge investment to set up a foundry. Okay, so that investment basically there was already an ecosystem which was available within IAC. So what we do is we we from the specs to the end product. So we provide the complete end-to-end solution on sensors, which could be your RF, you could be accelerometer, pressure, okay, and multiple sensors, whichever can be done. So we have established our own process. We are also being selected as one of the top 100 startup by Karnataka government, and so we offer from a prototype to the pilot production. And I'm here to sort of talk about what are the challenges, and obviously you feel free to ask me any questions with respect to fabrication. So that's it from my side, Himanshu. Thank you very much for calling me and inviting me for this event. Thank you.
Sure, sir. I'll be taking it forward with the questions. Sir, my first question is help me to understand that, like Nitika pointed out in the beginning, that India is emerging again is emerging as one of the semiconductor manufacturing industry for the future. What are the challenges that we face specific to India in terms of the semiconductor manufacturing?
Okay. So can I take this? Or
Sure, sir.
okay, see, I think okay, you were talking about semiconductor now. We've been hearing the semiconductor from last 20 years, okay, and we've been continuously trying to establish a foundry in India for I think close to a decade now, okay. And it's not easy to set up a semiconductor foundry because it requires a lot of natural resource. Okay. There is you need a lot of water, you need a clean environment. There are multiple challenges. But then overall, if I ask you if you want to know about what are the current challenges with semiconductor, I think one of the things is we need to have more material, advanced material. Okay, so the reliability on silicon is so high. Okay, we need to look into other materials like gallium nitride, silicon carbide, carbon nanotube. So there are other materials which we have to sort of bring into the advancement in this technology. On top of this, I think the equipment what we use, okay, there is a lot of advancement because we are into currently. I think we're talking about 1 nanometer. Okay, that's the resolution, okay, for the chip. And with the current infrastructure, with the equipment, I think we need to have a lot of improvement. There has to be new methodology, like you need to have an atomic layer deposition kind of equipment that should come in, which can address these smaller feature size. Again, I can the list is it's a big list which can you have to have a AI in your foundry where you can actually look for breakdowns. You have a lot of data coming in. You have to have a quantum computing which should be integrated. So again, there are a lot of advancement which can be done, okay, within that. But India still needs to have a basic setup, which I think work is in progress, and then shortly we will be there.
Okay.
So,
Talking
Ramam,
about the
just to interrupt you, Manju, Ramam, when I was reading about the semiconductors, when we do the research, we also got to know that India has some environmental sustainability challenge also to manufacture these semiconductors, as some gases or like hazardous gases were there. So, is how to overcome that challenge? Like, I feel that it is a major challenge in India. That's why manufacturing is in the nascent stage.
Okay, so I'll tell you about clean room. I don't know, not many people know about it. The more dangerous place is the clean room. Okay, it's the most hazardous chemicals. Whatever you see in your periodic table, okay, all the chemicals are there in clean room. Okay, so the safety has to be utmost. Okay, and any small accident could lead to a major disaster. Okay. And so again, sustainability, because as you have mentioned that there's a lot of natural resources required. Okay? You need a lot of electricity. Okay, I'll just give you an example. Okay, a clean room which is in IAC, okay, which has a power backup, which can basically light up entire Malaysian and also Kerala. Okay, so that is the kind of backup you need. There's a huge power requirement. Okay, a huge water requirement. So again, so these are basically if you want to get into a more sustainability and environmental friendly, I think there is a lot of new material is one of the key thing which has to be coming, okay, so that we sort of bring down this uh, dependency on silicon heavily, okay, and then you also need to have a uh, longer life of your electronics. Okay, but what is happening is I think the what I see is again it's also our responsibility to use the phone for a longer time. People change phone every 2 years. That's
Yeah,
not right
yeah.
because you change phone and that which means that new phone has to be produced and then you need more electronics. Okay, so there are many factors which is critical. Okay, and I think there is also a lot of carbon emission which people are trying to reduce. Okay, we are trying to make our chip less power hungry. Okay, we are trying to coming up with new methodology, new architect. So there is a lot of things which is sort of coming in to sort of reduce the what is the stress on the environment. Okay, and sustainability also.
And
I hope
just
I
adding to
answered.
the
Yeah.
yeah, and just adding to that, Raman, because he has already highlighted on the phones and all. Because if you just look into the kind of electronic waste across the globe, it's too much, right? So we don't have any kind of mechanism where we can recycle it. So anybody can, you can just look around you, you will find that is somebody will have a kind of old phone or whatever it is just lying and they are not using it. So it's not just a kind of how we are just producing, but how we are recycling is very much important in terms of, and ultimate goal is just to how we can reduce the carbon footprints, which everybody is trying to do that. And also how we can just make it more compatible, because the moment the technology will get enhanced, it will be a lot of challenges in the hardware systems and all. It can be used, cannot be used, so we have to think that is how we are just getting the things, or a chip or the hardware product get recycled, and also making it compatible going forward. This is also very much important, which I feel that is India is trying to learn, and because we're still trying to go up in terms of the semiconductor industry and all. So yeah, and also how best you can provide the very compatible chip solutions and all to support the kind of data volume on the front of the or perspective of the software industry. Because I feel that is the kind of data volume we are expecting to simulate and understand. There is a lot of understanding, or because that is coming from the hardware industry only, and that actually can needs to be innovate more. This is what I feel. And bio based polymer based biopolymer based kind of material and all definitely needs to be innovated. So yeah. So yeah.
Okay.
I
I
am
would like.
agreed the both for this. I'm steps for most challenges in the supply chain. Supply chain is the first most challenges for disruption, and then automation challenges for India also. Automation improves ROI, yield. Production yield is also most important for manufacturing of semiconductor in India because of the yield. Production is yield is mostly very small in India, and automation is most important for ROI, and contamination risk is also there in India. Wafer with dust particles, even in a clean room. Errors can occur when testing performance criteria to reduce till risk performance evaluation in intrinsic automated using system. We use all automotive system in the process also and in testing also. Testing also we are doing it with automation. Semiconductor manufacturing must not stop investing in human and AI oversights to make sure their automation frameworks stay on the top of tuning of his wafer, silicon wafer fabrication and other processes. This is the my first challenges for semiconductor future in India.
Can you share us some more insights related to that? Are there any, you cited about the challenges, are there any recent breakthroughs or development that have the potential to revolutionize or transform the industry?
Yeah, equipment manufacturers may capture growth by creating the machinery required, enable in edge innovating with advanced technologies. And renewable energy is also most important part for the semiconductor industries. As per many semiconductor manufacturing fabs use fossil fuels power their operations, and one of the steps towards achieving semiconductor sustainability is wind renewable energy sources. Most semiconductor manufacturing facilities require large amounts of electricity power and the produce processes. Now we are going also with plastic packaging semiconductor, with green semiconductor also we are going.
Okay. I
I
would
think
like to quick.
there are also like new technologies which are coming up in the manufacturing of semiconductors, like
Yes.
lithography, photolithography, then NAND
Lithography.
flash memory, quantum dots, then you
Yeah.
can say nanotube transistors. These are some technologies which are coming in semiconductors. So for these are some these are some technologies that can overcome few challenges for the semiconductor manufacturing in India.
Okay.
Yes, this is also challenges for cleaning only.
Right.
Right.
Clean is most important part for the challenges in photolithography area.
Right.
Okay. So,
Just to
like
add,
you mentioned that
sorry,
automation.
Yeah.
Yeah.
just to add here,
Yeah.
because what is the breakthrough in development? Okay, I think initially all your semiconductor is like stacked up. Okay, this is not.
That's
So
true.
what we are doing now is we are sort of also doing vertical, okay, so which is called FinFET, which has already come in, and the next advancement is also, so any space which is left, okay, we want to use it. Okay. So that is something which is coming up drastically. So there are ICs are becoming a 3D structures now. They are no more a 2D. Okay, that's one number one. There are also advancement with respect to your processing, as I mentioned earlier. Okay, so what we used to use in micron scale, okay, then we move to nano, okay, and we're going to go sub nano now, okay, and the conventional equipment is not going to fit into the sub nano ecosystem. You have to upgrade. So we are actually moving into something called ALD, okay, or which is called atomic layer deposition or etching. Okay, you can, so we're going to have more advanced equipments which are going to be in place to sort of overcome these kind of challenges which we are going to face in next, let's say, I think next 3 years, because the way the nodes are changing. Okay, just sure the audiences know here. Okay, there is, we say similar in nodes 180 nanometer, like 60 nanometer, 45, 28, 8, 5. Now we are in one almost. Okay, I think one is still not a production ready. It should be out in some time. But the next is what? Okay, we go below nano or sub nano. Right? So that's where I think more advancement is required. So I just wanted to add Ketu's point. Thanks.
Coming back to Keto, you mentioned about the automation and the ROI, that how these
Yeah.
two things can help us to better structure or to speed up the process of the semiconductor manufacturing. I
Yes.
want to ask that how AI and automation, what are their impact in the semiconductor manufacturing processes in general? Are there any countries who have implemented it, and how does it transforms it, and what are their future prospects?
Yes, as per future prospects, we are in semiconductor manufacturing. We are already using automation in Ratansa International Rectifier, presently also there, for photolithography, silicon wafers from potting of resist to remove of resist. Totally process is automation. We are doing that. And next, we are from Japan. We are also technology transfer from Japan for automation because of the yield. Production yield is not good for silicon wafers. Thickness is very thin. So our wastage of the product is more if human being in work everywhere. So automation is most important for yield semiconductor, also in diffusion section to alloying section, and in lapping section also.
Okay. Nitika, would you like to add something to that? That are there other instances where countries have come forward and implemented AI and automation into things?
Yeah, actually, the TSMC company and the Intel company is using AI to optimize the process control of its semiconductor manufacturing facilities. Even Samsung is using AI to automate their water wafer inspection and detect defect detection systems. And even ASML is using AI to automate their assembly of EUV lithography tools. So companies are using AI and automation for the manufacturing facilities and all.
Okay. Sandeep, would you like to add something to that?
Yeah, if we just talk about in terms of the AI technologies and all, if I'm just going from hardware, because ultimately how software is adopting the things, whatever the hardware is going to support, right? In that
Right.
scenario, we are just going to get the AI solutions done, majorly for the software industry. So if I'm just talking about my product, which I have worked earlier, that is the AI Ops, which is the artificial intelligence IT operations and all. And if you think in a bigger picture, everything is getting digitized and all. The kind of data volumes are there. You just consider any architecture where it involves infrastructure, network or whatsoever it is, and definitely we used to actually use some different kind of tools like for kind of sensing or having a sensor for the kind of heat that is producing and all for certain infra and all. There is some data which is going on. So what we are doing, the software industry, we are collecting the data from the different sources, simulating those data and all, providing the kind of alert to the customer and all. This is the kind of infrastructure needs to be upgraded and all. This actually also going to help to our customer to make sure that is their hardware product is actually upgraded and getting properly maintained and all. And also it's helping the customer to boost their business value and all. This is the kind of AI technology that we are using. But having said that, is that what we are expecting to do the simulation all that the hardware is going to support? And we are driving with that. I'm giving the one example, kind of the monolithic architecture which we have seen a long back, where a lot of servers used to get placed and all. That we are actually replacing with the cloud technologies and all, where you will find it that you're sitting anywhere, you're just connecting with the servers and all. So that kind of transformation, I would say, that is with the AI solutions and all that we are just achieving with the collaboration with the software and hardware together. So definitely lot of work needs to be done. But as I can say that the overall technology enhancement, the soul is something which is a hardware. How beautifully you are just making the semiconductor. Further on top of that, as a software industry, we are able to support and drive the business value to any customer. So, but there are a lot of challenges also, security and all that we have to see. That is how the data is moving, how we are sharing the informations and all with the kind of manufacturing industry. So so many things I would say, and a lot to be added. And but still we can see that is we have reached a long way till now, and expecting to get it more out of it. Yeah.
So, just
Okay.
to add what Sandeep has said, I think automation is there to increase the manufacturing efficiencies, as well as the automation help in workforce displacement. Just the task which is repetitive, another inspection process, assembly. So we can directly automate the task, and it will help in workforce displacement, I think.
Okay.
That's true. Yeah. Yeah.
I would like to go back to Raman. Raman pointed out in the beginning that there are the implications in terms of sustainability also. That these materials which we are using in terms of manufacturing of semiconductor, which we are using in semiconductor manufacturing, are also contributing to the emissions. So, are there any other innovative approaches or materials that we can use to reduce the environmental impact of semiconductor manufacturing?
Oh, it's hard to say. Okay, just give you an example. We say that EV is clean, correct? Great. We all love electric car. But the lithium battery which comes from this EV, okay, they are actually bad for the environment. And the way it's
Lithium
been,
ion batteries.
yeah, extremely. So, and even if you see overall consumption of EV, okay, basically there's lots of load on the power. Okay. You have to charge the EV, correct? So again, you are consuming so much of power, okay. And how do you generate power? So it's again, it's a, I would say, again, chicken story. Like still not sure. Okay, we are going to the alternate material. Okay, we are going to silicon carbide. We can go to carbon nanotubes. We are also, as Sandeep also mentioned, we can go into polymers. But then, how, what is the impact on the overall environment is still something which is still a debatable. Or I think I don't have the clarity on that yet. Okay, but yes, uh, I would say let's not have too much dependency, okay, on one single material, okay. Let's have different options, okay. For example, this gallium nitride, okay, which is now is coming into mainstream, okay, which is usually used for a high power IC. So which is actually good option because if you still you actually need more infrastructure or intelligence or resources to do a high power IC. Because gallium nitride is a better option when it goes to high power. So yeah, there are options which we are exploring for different materials. So again, it's hard to say anything at this point of time.
Okay. Raman, you mentioned about different materials, and Ketu also mentioned about diversifying or the dependence on the supply chain. My question to you is that in the current scenario, or if you look into the past 5 years, there was COVID, then there was war, and there again escalating tensions between countries. I want to understand that how geopolitical factors are impacting the semiconductor supply chain. We all have witnessed supply chain issues which during the time of COVID and the massive chip shortage. But what are the kind of strategies that we are now employing? What have we learned from that?
Okay, see, obviously, as you mentioned, the geopolitical is very important. Okay. I think we have clearly seen the impact during the COVID time where there was a shortage of chip, which in turn led to delay in cars. Okay, the car waiting time was 6 months, 8 months, I don't know, could be a year also. It was insane. So this situation is something which people realized. Okay, nobody gave notice to it earlier because our huge dependency of chip is from TSMC, which is a Taiwanese foundry. I think Anchal mentioned in a report that 50%. I think it's slightly more than that. It should be around 60, 70% of the chips across globe comes from TSMC. Okay. And who are the other player is Intel, Samsung. So in the recent time, what has happened is people sort of took notice of this, okay, that these kind of situations can arise more. Okay. So that's the reason why Europe is now geared up and they are doing a huge investment on setting up the ecosystem. Similarly, US has allocated a huge, I don't know, I don't remember the exact number, but some billions of dollars to set up their own ecosystem for IC. It's not that it's not there. It was there, but I think it was not there at the scale that is required. So similarly, India is coming up with now. I can see that India is speeding up and sort of starting to create that complete ecosystem. Okay, where you have a foundry, you have assembly unit, you have test unit. Okay, you have the raw material also. Okay, so we are trying to create that ecosystem, and obviously it cannot be done overnight. You need to rely on a lot of raw material from China or from different parts of the world. Okay, so there is good impact, but I think it's again we are trying to sort of create an ecosystem where we should be able to self-sustain the entire thing by ourselves. We don't have to rely on a third country or a third party.
And in fact, one thing I would like to add, as Raman also alluded, that is, and your data points like China or maybe Taiwan is something, leading on that in terms of semiconductor industry and all. We can see that is we are good into the software part, India, and US is also, relying on lot of chip-based market and all. If you just talk about, because you mentioned the geopolitical, so we are already seeing that is the world has divided into two area, in terms of the kind of like after Ukraine, Russia war and all, China, Russia is just getting. So if I can just highlight that it's not only about the chip manufacturing, there is a lot of lying in terms of security. US don't want that is other country like China and all. They actually control their security because US Army is totally capable with the kind of technology they are using and a lot of dependency on the chip side and all. I can give you one example because I personally know how this came into picture. If you know about the Broadcom in
Yeah.
2018 when Broadcom tried to acquire Qualcomm because they wanted to have a kind of big market share. US government actually put a halt on this because they found it as a kind of security challenge because a lot of US army were dependent on the kind of. So it's not only about kind of who is leading and all. That's why this geopolitical scenario creating a lot of push to make sustainability among within the country itself. India is also trying to get involved into that. They try to get with the Micron, kind of tie up and all, but could not hand. But still, India is trying. And same with the US is also trying. That is, they should have a very reliable partner because security should be the top priority. It's not about just we have to just get into the China. You don't know China how they're just providing the design, material and all to the third parties, other party. Having said that, just to get into the market, Broadcom now shifted their office to US because they initially domicile was it was based on the Singapore. The moment it got denied by the US government, that is you have to be in the US. So to acquire the company, or they shifted their office to US. This kind of geopolitical aspect is considering to drive the semiconductor market. So lot of impact, I would say, and that actually pushing a lot different countries to be self reliant on what they are expecting.
Okay. I would
So,
like to
Sandeep,
quickly go back to
is there
Ketu.
any impact of Russia-Ukraine war and the semiconductor industry? You feel that?
Once again, Achal, I could not understand the first and second. Yeah.
I was just saying that there was an ongoing Russia-Ukraine war since so many years. Right. So, what do
Hmm.
you feel that is the impact of that war is in semiconductor industry too? Because
So, first to answer your question, any wars will have a cascading effect, right? It's not just we can point out. The moment you will look into the kind of Russia Ukraine war, maybe Israel war or whatever it is, that will destabilize the different area, different factors. It can be a job cut also. That can also indirectly. The moment you see the job cut, what exactly will do? You will try to replace the human resource with the kind of technology and all that can also push. If you're just trying to look, that is the kind of the economy which Russia or Ukraine must be having, they will cut down their resource. And so there can be a impact on the both side, in the positive side and negative side. So it's any kind of war will definitely have a kind of. And then the moment I say that is war, because it's at the more of the division of the two global world. Here it actually push you hard in terms of deciding, that is how you can just be a self-reliant. Because why I'm saying, if you're just relying too much on the China, maybe Russia, it will be detrimental for them if you're finding them as an enemy. So the moment you will take a stand, that is I am in support of China, then you will feel like that is okay. We have to be make ourselves more reliant. Then you will start pushing yourself and look for the new market. So definitely, indirectly or directly, will have the impact whatever scenario you consider. And we have already feel that, and the kind of recessions and all kind of automations and all. COVID has the impact. COVID has a related to virus, but we found it the huge surge in the semiconductors. A lot of laptops were required, a lot of automation required. There's nothing related to virus with the technology, but it has a cascading effect. So this is the way I just take all any kind of wars that can lead to any kind of different situation to the global world.
If I'll add one point to the uh, points that Sandeep has put, Samsung is also working with their government to develop policies to support the semiconductor industry, and is planning to expand in Vietnam and US also,
Yeah,
Okay.
yeah,
to like
yeah.
which will decrease the reliance of on the China for semiconductors.
Okay. Ketu, what are your views on the same?
Yes, yes. Please again question.
What is the impact of the geopolitical factors on the overall supply
Yes.
chain?
Yes, about the supply chain geopolitical effect is also on our semiconductor future for India, but not more than enough. But also from my point of view, there is that is open innovation implies in willingness to allow knowledge of the our engineers is also challenges in semiconductor field. Now we are tie up with some universities for with the new course of the semiconductors, and new engineers is come up with this knowledge. This is also a challenge for semiconductor knowledge also for India.
Okay. I would like to go back to Sandeep for this one. Sandeep, you mentioned about particularly one incident related to the company. So, as we all know that the semiconductor industry is growing, so there are also additional concerns pertaining to security and reliability. So, how are these concerns being addressed, particularly in case of IoT and critical infrastructure-based applications?
Okay. Yeah, security is the biggest concern because the moment any enterprise is trying to get the security aspects consider, uh, they do have their data privacy security for their customers and all, because ultimately the major user, it can be a consumer, direct consumer, it can be enterprise. So what it happens that is, in terms of security, there is a lot of manufacturing hub and all, including in China. They also trying to delegate the work to the third party and all, right? So any enterprise will be concerned about that is, okay, this is a company from which we are just buying the kind of chip or whatsoever the hardware product and all. So what kind of knowledge sharing that is happening, that is a big concern. Is that going to impact in future and all, right? If we are just relying on the chip based company, which we are just using for our any sort of product, so is that actually flowing with a certain data to certain extent and all, even after using what kind of technology they have used? So lot of thing which is there in the cloud environment also. We see that is every second day, third day, or maybe kind of year or so, you will find a new technology, right? And that new technology should be supported by the hardware and all. That is also very much challenging. You don't know. You have to maintain your pace with the current business environment, as well as to make sure that your hardware is going to support and should be secure. So, a lot of these concerns, and I would say the best way to address it, you need to formalize the kind of compliance process and all. Need to very careful in terms of that is how the companies are following and all, and how you can just rely in terms of to get the things done with the secure environment. As I mentioned, that is the kind of that is who is your enemy and all, but still you're relying on, because you don't have any kind of so what you can do, like you can just develop your trusted partners, which every country is trying to do that. Rely on the kind of work they are doing and all, and then these kind of security challenges can be overcome. And then I have to make sure that is whatever you are opting should be secure with the future technologies also, if we are just adopting. So these kind of things, because you don't know ultimately what we are looking and what exactly is pushing you in the semiconductor industry. That is, if anything which you are looking for the mobility kind of thing, you will look for the most compact hardware solution with the higher capability and all. That is the whole area which we are just looking into, be it a smartphone. We want everything. We want a smartphone should work like a computer and all, and then should be movable and all. So these kind of scenario, you have to be very careful in terms of what exactly you are going to adopt and get it secured.
So I was
Okay.
just going through an article yesterday. If we talk about the cybersecurity threats in semiconductor industry, so some of the manufacturers are actually implementing the robust security features in semiconductor components, like we can say hardware-based encryption, then secure boot processes
Crypto.
and tamper-resistant components, just to robust their security functions in semiconductors.
Okay.
Yeah, definitely. Even if you just talk about the cryptography and all, these all are the or encryption kind of thing which we are just using. Any software, how the one legitimate person or a legitimate user should actually able to access the the data which you're transmitting from one device to another. That is very much important to implement. And encryption is going to be a big way. But definitely, whenever you are just going ahead, you have to be very careful in terms of, is it something, if you're just going ahead breaching the security and all that, and it starts from the hardware, I would say. As I mentioned, keep mentioning, that is the soul of any kind of technology is the hardware. So how hardware is actually configured to get it to the end user, that is very much important to understand the security level which you are going. You can further on top of hardware, before the end user consumes the data and all, you can implement so many things, but you don't know where is the leakage and all during those transmission of the data and all. So very much important. It starts from the hardware and then reaching to the user level. Yeah.
Okay. So, as we are all are aware about the recent rollout of 5G in the country, are there with the recent rollout of the 5G, how the design and the manufacturing of the semiconductor is changing, particularly in case of mobile devices and IoT?
Okay. Uh,
Raman?
yeah. Okay. Uh, yeah. Okay. What is 5G? 5G is basically where um, the data speed is high. You are then. It's just not about mobile phone and watching movies. It goes beyond that. Okay. Yeah. Okay. I think a lot of people think 5G is all about watching movies at a more clear picture or whatever high definition. But actually, 5G as a we need high speed data. Okay. We need high speed data for banking. We need speed data for our defense. We need high speed data in aircraft. So we need everywhere. Okay. And 5G has actually opened up a huge market. Okay. So if the 5G technology already come in, so obviously you have all upgraded your phone, correct, from 4G to 5G. So there's a different kind of chipset which is required for 5G. So and also the communication system, the big towers which you had seen earlier. Okay, now it's become more smaller, and I think it's like module. It's more modular. Okay, that's the kind of increment with respect to 5G. But again, 5G is also very demanding technology. It requires a lot of power. It requires a lot of energy. Okay, it has to be more reliable. Okay, so I think towards that there is a lot of work which has been done. Okay, and just coming back to a question of what is the impact of 5G on semiconductor ecosystem, obviously it has. So this is something which has actually given a lot of boost to the industry, to the market, and but it also comes with some challenges. I think which has already been addressed, okay? And I think people are now working on the 6G. Okay, what need to be done for 6G? Yeah. Anything else you wanted to add here, Manju?
Yeah, I just want to know that how semiconductor would be playing the role in terms of the expansion of the IoT ecosystem.
Yeah, it's already there, correct? 5G is already there, IoT is already there. Okay, and I think I feel that in some time the 5G will saturate. Okay, because then people need to move to 6G. So I think
That's
all the
true.
infrastructure. I think India is already gearing up. I think we have now most of the major cities have 5G. Okay, and the kind of infrastructure which is required, especially on the semiconductor side. Okay, again, none of the chips are made here. Okay, and let's say for as I mentioned earlier, also the material called gallium nitride. Okay, which is a substitute to silicon. Okay, it is going to be predominantly used only for all the telecommunication, especially on the 5G side. So it's going to disrupt the way we are doing things, okay, which is already happening.
Okay. That's great, sir. That's all the questions we have received from the attendees today. I want to thank each one of you individually for
One more
joining.
question I have, Himanshu. Sorry to interrupt.
Yeah, sure,
Actually,
absolutely.
I want to understand the relation between renewable energy and semiconductors. Is there any, if we talk about environmental sustainability, can we use renewable like solar, wind, or hydro in semiconductor manufacturing to reduce the impact or greenhouse gases or carbon emissions in the semiconductor industry? Is there any relation?
Yeah, in a
Yeah.
sense. Yeah, yeah. Please, Ketu, you go ahead. Then
Yes. Yes.
you probably can answer this better than me. Yeah.
Yes, it is both of a relation called semiconductor and with solar chips. Solar chips is also same semiconductor. There is nothing but solar chips is semiconductor. And with renewable energy, air energy, water energy, all is we are used with the semiconductor manufacturing processes, and must be we are used with semiconductor if we are manufacturing in India. This is the most important part, and relation is also always there.
Just to add here, okay, I think we
Yeah,
are all
yeah,
moving to green energy, correct? Like right from your
yeah,
house, okay, we're moving solar power. So yeah, it will gradually come because the whole semiconductor foundry is very power hungry. Okay, that requires a lot of power. Okay, and I
yeah,
think these solar plants and thermal is still going to be a challenge. Okay, because uh, it's again the efficiency is less, correct, compared to a conventional power grids. So, but I think over a period of time, I was recently seeing this Apple ad where they're saying they're actually going carbon neutral. Okay, in their plant.
Yeah.
They have a lot of solar plants. I think this is work in progress, and shortly you will see uh, that all these fab foundries they run on solar or wind. Yeah, but then you have to also see that see the too much of wind is not good for a semiconductor foundry because if it's too windy because you are actually working on a nano scale and slight
Yeah.
vibration can actually
True.
spoil your chip. So yeah, but I'm sure there'll be some arrangements. Okay, so but yeah, there is something I think I have not personally looked into it, but I think it's a good question answer that why can't we sort of work with more green energy? I think that's something even I will look into it.
So, is there any country right now who is using renewables for semiconductors? Because I personally don't know this.
Okay,
Is
the
there
thing
any
is,
country?
the first objective is not about see when you start anything, correct? You sort of don't even care about the environment or energy, green energy. So what you want to achieve is to get the product out. I think mostly in India that's the objective. Okay, I'm not even worried that from where the power is going to be green power or not. Okay, how environmental friendly at this point of time. But I think people who are matured. I don't know. Probably Samsung and US there could be some foundry who have sort of taken the initiative. See, I see from Apple saying all about green energy. Okay, they don't give you plastic box. Okay, but that they have reached a big maturity level. Whereas I have not heard TSMC claiming that they want to be a green company. So I don't know. Probably we have to look into internet and find whether is any foundry which is already sort of adopting green energy or not. I personally don't know. But yeah, interesting question answer. I think you should put it across to all the events in ISA events where you should say that okay, great, you're making the chip, but is your power which you are using is it green or not? Okay, what is the carbon emission? What is the carbon footprint?
Right.
It's an interesting question. Okay.
But I'll get back to you for the answer too.
Sure, sure, no worries. I'll work on it.
Great. So thank you all the speakers for joining us today and shedding important light on the for the discussion that we are having. We had this today on the future of the manufacturing. I hope all of our attendees enjoyed a lot and got answers to all of the questions that they have raised over the past few weeks. Thank you, everyone.
Thank
Thank
you.
you
Thanks
everyone.
everyone. Thanks
This
panelists
was
for
a good
joining us.
session and interactive session. Thanks a lot.
Thank you.
Thank you,
Have a nice
everyone.
day, a good week. Bye bye.
You too, guys.
Thanks.